Okay, so now here are a couple of examples that put it all together. So here is f of x equals 5 cube root of x minus 3, that says fifth root of x to the fourth, and our job is to find the derivative of each function. All right, so first we're going to rewrite the function. So that, think of that as a separate step. I am not doing calculus on this first step. I am only doing algebra. This is 5x to the 1/3, and then I have minus 3x to the 4/5. All right? Now I'm going to do calculus. So now instead of writing f of x, I'm going to write f prime of x. So be clear about when you're still working with the original function and when you're computing the derivative. All right, now I got to multiply 1/3 times 5, so that's 5/3 x. I got to think, what's 1 less than 1/3? Hey, what's 1 less than 1/3? Yeah, it's negative 2/3. Negative 2/3, okay? And then I have to go 4/5 times 3. It's going to be negative. Negative times positive is negative. So that's going to be, I can just write this minus 12/5. And then it's x to the, hey, what's 1 less than 4/5? Huh? What's 1 less than 4/5? Negative 1/5. Okay? Now, I encourage you to write your final answer in terms of roots and powers. It's excellent exercise. So this is going to be 5/3 cube root of x squared, right? So see how I've kept the fraction 5/3, and then my x has a negative exponent, so the x is going in the denominator. The 2 is a power, the 3 is a root. Right, and then I have minus, I'm going to do the same thing with this one, 12/5. This time I just have x to the 1/5 power, so it's fifth root of x. So that is my final answer for number 1 there. F prime is, yeah. Now you try and do this one. Pause the video, do this one, then come back. All right, are you back? So first step. Now look, a lot of people get confused because they'll start doing 68x cubed plus 30x squared, and they'll get here and say, oh, I have to rewrite this as 2x to the negative 1/2. Okay, but what's going on then is you're doing the derivatives of these parts, but not these parts, and you have something that is mixed, the derivative and the function. Be clear, deal with one thing at a time. When I rewrite the function, I have to rewrite these two terms, but I'm going to keep these the same. Rewrite them. It's not going to hurt you. You're not going to get carpal tunnel syndrome just from writing out a polynomial, okay? And then I'm going to put this plus 2x to the negative 1/2 minus 5x to the negative 10/3. All right, so I'm just rewriting the function. This is algebra 2, it's not calculus. This is f, this is f. These terms stayed the same. These ones are rewritten, okay? Then I'm going to find f prime of x. Now I'm going to do calculus. Now I'm going to do 4 times 17 is 68 and have x cubed, so now I'm dropping at 1. All right, don't mix this step with this step. That's what I'm saying. If you have this and then you have this in the same line, then you have some things that are derivatives and some things that are not. And that is not clear. So now we have 30x squared. It's not only not clear, it's not correct. Minus 18. So remember, when I have a linear term like 18x, it just becomes a constant. When I have a constant term, it becomes 0, so it goes away. So we're going to be in the habit of just not writing constant terms because they're going to go to 0. All right, negative 1/2 times 2 is negative 1, so I'm just going to put negative x. 1 less than negative 1/2 is negative 3/2. And then negative times negative is positive. I have 5 times 10/3, so I'm just going to call it 50/3. I'm not going to work any harder than that. Minus to the negative, okay? And 1 less than 10/3, what's that, huh? It's 13/3. All right, got to know your fractions. You really got to know your fractions. All right, now I'm going to be nice and rewrite these last two terms in terms of radicals. My first 3 terms are fine, though, so I'm going to leave them alone. 68x cubed, but I'm going to be clear that this is f prime, right? This is f, this is f, this is f prime, this is f prime. All right, being clear about what I'm writing and what it means. So minus, let's see, so this is going to be 1 over the square root of x cubed, right? This is really so you notice how the square root is a second root. Usually when we omit a number, it's either 0 or 1. In this case, the omitted number is really a 2. The implied number, I guess we could put it that way. The implied root is always 2. Weird, huh? And then here I'm going to make a nice fraction. Put that, balance that 50 in the middle, and then 3, and then it looks like I have a cube root of x to the 13th. You could simplify this and make it, what would that be, like x to the 4th power cube root of x, right? You could do that, x 4th power cube root x, simplify that. But it doesn't really make it any nicer. So I think I would be inclined to leave it like that and say that is my answer to number 2. I hope that is the answer that you got to number 2. Now, on the Google Classroom and also on the handouts page of the website is posted your homework, being my good friend John Rogowski. We're doing page 139. Be careful of this weird assignment I'm giving you. It's number 7 through 43 odd, except the ones that we didn't do yet, which is 19, 29, 31, and 41. We're going to do those next time, but we have to learn how to do the derivatives of e to the x and sine and cosine. I guess it's just e to the x. Okay? Now, I'm going to actually go through an important notational device that Rogowski uses on this page 139 that's posted. It's really essential to see, and it's just like derivatives have so many different weird notations, and I'm going to just show you another one, and that's going to be in the next video. It's really important that you watch it in order to be able to do this homework correctly and understand it.